If you're struggling with scientific research, this podcast will explain the types of research and how to work safely in the laboratory. There are two types of scientific research. There is applied and pure. Pure research is when you research something just for the sake of the knowledge that can be gained from it. For instance, if I wanted to figure out why a plant grew a certain way, I could plant the plant, do the experiment, document all the different things that I did for the plant to ensure its growth, and at the end, I would have the knowledge that I gained at each step of the way. Whereas applied is more like when you have a situation, a problem. For instance, the epidemic of AIDS or the ozone depletion. Those type of things would be examples of applied research. There's a specific goal that you have in mind that you are working to research and be able to correct whatever problem is going on based on that research. So we have two types of research. They are applied and they are pure. An example of the CFCs, which are chemicals that deplete our ozone, there were two individuals by the name of Malone and Rowland, and they were scientists who, just for the sake of wanting to understand information about CFCs, conducted a bunch of experiments. Their pure research resulted in a hypothesis that was supported in the laboratory, which said the ozone's being depleted because of CFCs. And it wasn't till 1985 when there was actually concrete evidence that the ozone was being depleted and that there's a possibility of a hole being created in the ozone. Well, at that point, because of the research of the other two scientists that had done it just for the sake of learning about how things work and the curiosity they had with CFCs, they were able to apply the information and be able to work towards banning CFCs so the ozone would stop the process of the ozone reduction. What's amazing is, in the field of science, research does not always end up exactly the way the scientists expect. Many times their discoveries come by happenstance or by accident. An example of that would be when I.E. DuPont, with his company, was trying to come up with something to replace silk. And so he had done all kinds of different experiments and they were trying all different kinds of chemicals. Well, one day, one of his team members put a glass substance into the mixture that was going on, and when he did, he pulled it out, and when it pulled it out in long strands, and these long strands were strong. So it ended up that that was the creation of nylon. And it was truly just because someone in his group wanted just to see what would happen if you put glass into the vat as they were doing their experiments. This nylon was very helpful during World War II, and they used it for parachutes. And today, nylon is used in all kinds of textiles and some plastics. Now, we've talked a little bit about the research, but in order to get the research completed, there has to be time in the lab, and we all need to be safe when we work in the lab. Safety is not just for ourselves, but also for the other people that are located in the lab with us. So there's several different steps that we need to do. One of which is any project or any type of experiment that's being conducted, you need to have permission to do it. You need to have researched it enough to know the different things that you're going to be working with. Are they toxic or are they not? You need to be able to read the label to make sure that none of the substances that you're working with or the combination thereof would result in something being hazardous. In preparation, you need to have goggles, gloves, an apron. You need to have clothes and jewelry that are not dangling, or hair that is not hanging down. So anyone with long hair should be sure to pull it back. Some other precautions are closed-toed shoes. Some people think, oh, well, I wear contacts, then I shouldn't have to worry about taking them out when I work in the lab because I have goggles on. Contacts are very porous and they will hold a protective barrier of whatever they get underneath them. So it's a good idea to take out the contacts when you're working in the lab with certain substances. Some other things that are good to do is if you have an accident in the lab or an injury or you have an incorrect procedure that was involved, it's important to report those. If you have any broken glass, you have any, there should be a container to put all broken glass. When you're disposing of chemicals, you need to follow the instructions on the bottle. You need to make sure that you are not combining certain things with water that would cause another type of reaction that would not be favorable. You never take a test tube and look into it or point it towards someone or towards yourself. That's always a safe practice. You need to know where to find and how to use the fire extinguisher, safety shower, fire blanket, and first aid kit. The other thing is that there are usually in most labs there are fume hoods. So if you're working with toxic chemicals that would cause you to have the possibility of bodily injury or affect other people, it's very important that you use the fume hood. And that's where it would suck out or suck up any of the fumes that would be involved. For instance, if you were using a Bunsen burner or something to heat up a chemical. When you're measuring things with a balance, it's important not to put the chemicals directly on the balance. They need to be put into some type of container first. Never taste any type of chemical. It's vital that you are very safe and use precautions in regards to working in the lab. When you use acids and bases, you need to understand the combination with water and how that affects it. And any chemicals that you're disposing of, you need to make sure that you do it in a correct way. Know the correct procedure for preparing your workstation. Make sure that when you take chemicals that you only take enough that you need for your particular experiment. You don't take the entire bottle over to where you're working. The other thing is that you never put pipette or a measuring back into the bottle, or you never put what wasn't used back into the actual source container. When you're finished, after completing an experiment, you clean your work area and your equipment, and you make sure that the gas and water are turned off. Wash your hands and soap and water before leaving the lab. The benefits of chemistry include research from both applied and pure research. We also need to be very careful when we're doing that research and that we follow the guidelines that will keep us safe in the lab. Although applied research is easy to understand because it addresses specific problems and therefore we can see an immediate benefit, the application of pure research is vital when there is something that happens that's unexpected in our world. That previous research that was done just for the love of research is the launching pad to make sure that we can build and come up with applied research that will help resolve situations and be the solution. Technology is the practical use of both pure and applied research. Some technological advancements have improved human life, like nuclear power, artificial limbs, joints, those type of things. If you have further questions, you can go to the next podcast that discusses additional discoveries through technology, applied, and pure research. Thank you for your time.